What is up, Notorious? Today we are going to solve some old questions from IOE 2071 Shrawan, and this is gonna be communication 2. The question is asking about the importance of source coding in digital communication systems. We know that source coding, the information of the digital communication systems are in discrete form, and these discrete symbols are converted to binary sequence of ones and zero by assigning code words to them. So let's take an example. So suppose we have discrete values of A, R, S, and P. When we give that to source coder, the output in the form of binary values. There are two types of source coding techniques, and one is the fixed length coding techniques, and another is the variable length coding technique, which is very famous, Hoffman coding and Shrawan coding. Now coming to the numerical part, given informations are discrete memoryless source emits one of the 8 symbols with the probabilities are given, and the symbol rate is 1000 symbols per second, and the output symbols are coded using Hoffman coding. So the questions ask code efficiency and output bit. So little bit of background theory here. Hoffman coding is the lossless data compression technique. So to solve the numerical, let us suppose A to H be the probabilities, given probabilities, and in Hoffman coding what we do is we sort out them in ascending order, and we add the least two probabilities, and then we arrange the timeline of the given probabilities. So here we can see 0.02 and 0.03 adds up to 0.05, and since 0.05 is smaller than 0.07, it is kept to the left of 0.07. Now again 0.07 and 0.05 are added together to form 0.12, and since 0.08 is smaller than 0.12, it is kept to the left of the 0.12. Now doing the same process, that is adding the two least probabilities, and if the upcoming sum is greater than the other probabilities, then we keep it to the right of the probability, else it goes to the left side. So here we have when you add up 12 and 8, it will become 0.2. 0.2 is greater than 0.15, so it goes to the right of 0.15, and now we arrange the probabilities. So there are remaining 4 probabilities, so we again add 0.15 and 0.2 to give up 0.35, and then since 0.35 is greater than 0.02 and 0.25, sorry, so it goes to the rightmost side. Now the least two probabilities are 0.02, and both of them are added to form 0.4, and since 0.4 is greater than 0.35, it is kept to the right of the 0.35, and the least two probabilities now are 0.25 and 0.35, so these two are added together to form 0.6, and since 0.6 is greater than 0.4, it is kept to the right of 0.4, and these both probabilities are added to form unity, that is 1. Now the code length is how many steps does it take for each of these probabilities to go from 1. So let's label them. So this is A, and B, C, it is F, G, F, E, and D. So now to get to A from 1, we have to take 2 steps, so it has a length of 2. Similarly, B and C also has a length of 2, D has the length of 1 to 3, and E has a length of 4, F has a length of 5, and G and H have length of 6. Now the aggregate length is given by multiplying the length with the probabilities. So 0.25 is multiplied by 2, and similarly others are multiplied. So I'll just copy and paste this on Google to have the answer, and it is 2.72. Now we have to find out the entropy, that is denoted by H, and the formula to calculate the entropy is the probability into log 2 1 upon the probability. So it is the series of sum. So let's arrange it so that we can have a nice look at them, and we do it for each and every probabilities. So there will be 8 sums, and when we solve this, we get the value of H is 2.6639. Alright, then the question asks code efficiency, which is given by entropy upon length into 100%, that is equals to oops, oh, 97.93 percentage, and the output bit rate is given by this. All right, so it was a quick solution of question number 1, and we'll be adding other videos continuously. So see you guys in the next video. Till then,